Hello Legacy students, so today we're going to look at properties of logs, aka expanding and condensing them. These properties are going to definitely help us later when we start solving more complex equations using logs. You're going to want that foldable I gave you in class, notebook, and then a pencil, and definitely an open mind today, because this is not the easiest, but at the same time, for some people, this is one of the easiest sections of this unit. So, that foldable. Properties of logs. On the front here, we're going to put some information. You're also going to want to cut along the lines here. So cut here, cut there. So that way you can open the flaps. So the product property looks something like this. If I have log of whatever base, any base works, of A times B, I can rewrite that as log A plus log of B. And I'll explain why that's the case in a little bit here. Quotient property, if I have log of A divided by B, I can make that log of A minus log of B. And then the final one, the power property, if I have log of A to the B power, I can rewrite that as B times log of A. So, probably saying, there's no reason for why you're saying this. There is kind of. So why can we do this? Why? So log base 2 of x is equal to the exponent, right? Well, when do we add exponents? When I'm multiplying, right? So that's why on our product property, right now I'm multiplying on the inside, I'm adding the exponents. When do we divide? When do we subtract? When we're dividing. So that's why those two are paired. That's what, in my mind, when I see multiplication, I think addition, because that's how exponents work. When do we multiply exponents? Well, I multiply them when I have a power to a power, right? Which is ultimately what's going on when I have that log. If we convert it a little bit and do all of that. So, what are these exactly used for? Well, it's to take care of very scary looking problems, make them a little bit more simpler. This was also used a lot more commonly when people did not have the ability to type every single log into their calculator. So what they would do is they knew various information about it. So they knew like 35 was log of 7 plus log of 5. They could easily look those two up and just add the values. So what you're going to want to do is open up the tab, the product property tab. So open up this tab up here. This is where that information is going to go. So product property examples. So some expanding and also some condensing. So expanding is when you want to take it from one log to multiple logs. Expanding, you're going to, for everything that you have inside of the log, you're going to gain a log on that. So since this problem has two things inside here multiplied, I'm actually going to get two logs together. So multiplication becomes addition. So what I'm going to get from this problem is log base 3 of 5 plus log base 3 of x. So all I did is expanded it. I made it so if there's a multiplication, I put a plus with another log on it. And it's still just log base 3. This one, I got log base 10 of 6 to the times x times y. Notice I got 1, 2, 3 things multiplied in here, right? So that means I'm going to have 3 separate logs. So ultimately, what am I doing? I'm just splitting it up. So I got log base 10 of 6 plus log base 10 of x plus log base 10 of y. All I did is just split it up. I'm cutting up the inside to make it simpler looking as I expand. Now, let's say I want to condense it. When you're condensing something, You want to get down to one single log again. So this is going backwards of what we just did basically. So if I have a bunch of addition in the middle, that means ultimately, originally, everything inside of these logs were multiplied. So I can rewrite this as log base 3. Notice there's just one log base 3, and they all have to have the same base for me to condense. This would be 2 times 11 times 7, ultimately. So all I did is just multiply the insides. So if I do that quick, the actual answer to this problem would be log base 3 of 154. So just taking it and making it simpler. Now let's try the quotient property. Okay, so quotient property, expanding is similar to the product property, except when you see division, you're going to think subtraction. And how do I keep that in my mind straight? Because I know the exponent stuff probably doesn't stick, but I think division and subtraction, both things make things smaller, right? If I divide two numbers, usually it's going to be a smaller number. If I subtract, I get smaller. So that's how I kind of pair them in my mind so I don't forget. So if I have log base, oh, there's a 10 on that, to the 6 divided by x, right? So what I'm going to do is split this up. So it's going to be log of 6 minus log of x. So all I did is made this division sign. I just split it into two different logs with a minus in the middle. So let's try condensing as well. So condensing means I'm trying to put it back to a single log again. So that means anytime I see subtraction, I need to make it division. So this is technically log of 2 divided by 8. Or, if I simplify, 1 over 4. Now let's try this one. Log base 4 of 3 minus log base 4 of 8. So that would be log base 4 of 3 divided by 8. All I'm doing is just putting stuff together or expanding it, making it bigger, ultimately. Putting multiple logs in it. Taking it and chopping it into pieces. Power property. What are these used for? Well, it makes it a lot simpler. I don't have to deal with this whole like squared out here, because imagine having to solve something, converting exponents. It's gross. So product property or power property, what I can do is take this little exponent when I'm expanding and go poof, and drop it in front of the log, because basically all I'm doing is multiplying. So it's going to say 2 times log base 4 of a times b. My pen went a little wonky there. A times b. Now, times. Times changes. Times changes to addition. So technically this is 2 times all of this. Log base 4 of a plus log base 4 of b. Right? Because technically that 2 is to everybody. Another thing I could do, I could have given that 2 into both a and b. So it would have been log base 4 of a squared plus log base 4 of b squared. And then the 2 could sit in front of both of them. Ultimately, it would be the same answer, however. And let's try this one. So, ooh, square root. There's a square root on that 7. How do I take your square? Well, I'm going to split these, right? So I got log base 5 of square root of 7 plus log base 5 of x. Well, that square root's gross inside that log, right? Well, but square roots are just a number to the 1/2 power, right? So this is technically, right below, log base 5 of 7 to the 1/2 power. And I know exponents can go in front of a log. So technically, here's the expanded form of that log. So it'd be 1/2 log base 5 of 7 plus log base 5 of x. So all I did is take that exponent and move it in front. Now notice it's not like this one where I had the big giant parentheses, because that 1/2 was only on the 7. It was not to the x as well. The square root was not over the x. So let's try condensing here. So I have this exponent here, number in front of my log. I'm going to bloop, drop it in front. So I got log base 6 to the 1/3 power. And I know 1/3 power means I'm going to cube root that condense. Let's try a couple of multiple properties and then we're going to be done for the night. So when you're dealing with a bunch of properties all together, you are going to want to follow the same. So when you're expanding, you always want to take care of the power first. Okay, so take care of exponents. Then I like to take care of the quotient stuff. Oop, that's not how you spell quotient. Quotient. Let's try that again. Let's see if I can do it better this time. Quotient. There we go. And then 3, I'm going to take care of multiplication. Okay? So that's how I'm going to follow this one. So first thing I'm going to take is that 5. I'm going to drop it out in front. So this is 5 log of 6x divided by 11. Then I'm going to take care of the quotient. So I'm going to take care of this division. I'm going to make that subtraction. So it's going to be 5 log 6x minus log 11. Notice I have that 5 in the front because this 5 was to everybody in here, so I got to make sure I say that the 5's to everybody. And then also I have this multiplication in here, right, of 6x, because this is 6 times x. You just don't see that multiplication. So I do need to expand that even a little bit further. So that's log base 6 plus log of x minus log of 11. And it wouldn't be too bad either if you'd put parentheses around that, so then you know to take care of that as well. So, condensing. I almost do the exact same path here. So I take care of any powers that need to go back. Then I take care of any quotients, and then I take care of any multiplications. So, first thing I notice, this 4 needs to go back to be an exponent, and so does this 20 needs to go back. So I'm going to take care of those. Log base 3 of x to the 4th minus log base 3 of y to the 20th. All I'm doing is just moving them back to where they were originally. And now I need to condense fully, so that means I need to be down to one single log. Well, I see subtraction in the middle, so that tells me I need to divide the two insides. So it's going to be log base 3 of x to the 4th divided by y to the 20th. Now notice, guys, what condense does. Ultimately, it makes something look easier than that junk, right? It makes it easier to look at. Ultimately, why are we doing these? Well, it's going to help us solve equations when there's multiple logs on one side that we can shove together and make it cleaner. So ultimately, what I could start doing, since I see subtraction, I could combine those into a single log with division. So this would be log base 10 of, and I see that 2, so I can put that on the x. So it'd be 3 over x squared equals 16. And then ultimately, what would I do? I would convert to exponential form, and start to solve. It would be a very gross answer just because of it's for an example. But ultimately, this is what we're getting to. This is why we're learning these properties. I know they seem not very useful, but they are very, very useful, especially as you continue into calculus and pre-calculus as well. And with that, that's the end of this video. So I'll see you later, Sabers.